Dear students, let us begin the third part of the lesson in which you will learn about the relevance of retention and rejection of null hypothesis for statistical decision making. The question before the researcher is whether to reject or not to reject the null hypothesis or relevance of retention for statistical decision making. For the above purpose, it is essential to have concrete procedures. This essentially needs the below 4 values: significance level, calculated value, table value and p value. Significance level alpha and p value. The term significance level, which is denoted by alpha, refers to the pre-chosen probability, which the test statistics will reject even if the null hypothesis is true. The lower the significance level, the more the null hypothesis will be significant. The significance value alpha plays a role in the decision making process. For example, here the p value is 0.07 and alpha value is 0.10. According to the rule, p value is less than alpha value, therefore null hypothesis is rejected. In the second case, again the p value is 0.07, but alpha value is 0.05 and here p value is greater than alpha. The result is null hypothesis is not rejected. Therefore, if you compare, the left hand side is 0.07 in both the cases, but the right hand side the alpha value changes. In first case it is 0.10, in the second case it is 0.0. Because of this variation, you can see the null hypothesis is rejected in the first case, whereas the null hypothesis is not rejected in the second case. Decision making rule in hypothesis testing. Approach 1, table value. In this approach, we need two values. One is calculated value, that is obtained by substituting the test statistic and simplifying. Another one is table value. It is obtained from the statistical table book corresponding to the respective degrees of freedom. According to this rule, if calculated value is less than table value, then do not reject the null hypothesis. If calculated value is greater than or equal to table value, then reject the null hypothesis. Approach 2, p-value approach. A more information approach is to calculate and quote the p-value of the observed test statistic. Since it is tedious to calculate, we use statistical software to get it. The p-value is the lowest level at which H0 can be rejected. The smaller the p-value, the stronger the evidence against the null hypothesis. Decision rule. If p-value is less than level of significance alpha, then reject the null hypothesis. On the other hand, if p-value is greater than or equal to level of significance alpha, then do not reject the null hypothesis. This can be written symbolically as if p-value is less than alpha, reject the null hypothesis, and p-value is greater than or equal to alpha, do not reject the null hypothesis. It is important to note that acceptance of H0 is not equal to do not reject H0. A test enables us to either reject or not reject the null hypothesis. The phrase accept the null hypothesis is written by some researchers. The correct phrase should be do not reject the null hypothesis. Advantage of the p-value approach. The p-value approach provides the strength of data evidence to reject the null hypothesis. If the p-value less than alpha, then the null hypothesis is rejected. That is, the sample does not give reasonable evidence to support the null hypothesis. Advantage of the p-value approach. Several cutoff points can be used for p-value. They tell us about the strength of evidence or the support that the null hypothesis gets from the sample data. Typical cutoff points are listed below. Reject H0, p-value less than 0.001, very strong evidence against H0. When p lies between 0.001 and 0.01, strong evidence against H0. When p lies between 0.01 and 0.05, moderate evidence against H0. We do not reject H0 under the following cases. If p-value lies between 0.05 and 0.1, some evidence against H0. If p-value is greater than 0.1, little evidence against H0. While writing the inference, do not simply write null hypothesis rejected or not rejected. The researcher must incorporate the strength of evidence provided by the sample in the inference, whether it rejects H0 or it does not reject H0. As a summary, in this video, we learned parametric and non-parametric methods, need for non-parametric methods, nuances of null and alternative hypothesis, decision-making mechanism on null and alternative hypothesis. Students, I hope these concepts will be helpful to you in your research. We have concluded our lesson on the statistical decision making regarding retention and rejection of null hypothesis. Thank you.